All right, so just to kind of recap our rules that we have so far. So we have sine, sum, and difference. We have cosine, sum, and difference. Okay, so today, hopefully you would think we would do tangent. Okay, so the way that you're going to remember them, sine starts with sine. Cosine starts with cosine. In sine, the SIGN matches. In cosine, they're opposites. Each of them have two parts. First part before, second part after. So if this one starts with sine, then the second part starts with cosine. If this one starts with cosine, the second part starts with sine. Right? So again, I'm just trying to show you similarities in both of them. So sine has each of it. It goes sine, cosine, cosine, sine, and cosine has the same. Cosine, cosine, sine, sine. They all start with A's and end with B's. So again, just trying to get you to remember those formulas. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay? All right, so I am going to pick one number. And I'm going to tell some people to do sine sum, some people to do sine difference, cosine sum, cosine difference. All right, so let's try to think of a number we didn't pick yesterday. I am bad at this, picking different numbers. Let's pick, I don't think we picked 255 yesterday. Did we do 255? I don't know if we did. I don't think we did. Okay, so we're going to split it up, right? So sine sum, sine difference, cosine sum, cosine difference, sine sum, sine difference, sine, cosine sum, cosine difference, sine sum, sine difference, cosine sum, cosine difference, sine sum, sine difference, cosine sum, cosine difference. So I got 3 people, I think, 4 people doing all of them. Okay, so do whichever one I told you to do for 255. I got 4 people doing each of them. You can do whatever you want as long as it's a subtraction. You can do whatever you want. Remember, you're going to check yourself. So I'm going to give you the decimals of what the sine of 255 is. Negative 0.9659. Cosine is negative 0.2588. You're going to check what you're getting as your answer. Rad 6 minus rad 2 over 4, negative rad 2 plus rad 6 over 4, plus, right? Whatever it's supposed to be. And you're checking your fraction and seeing what you got. Anybody that had a sum, what are you guys using to add stuff? What numbers are you using? Anybody that had a sum? Say it again. 45 and 210. Any other numbers that you're using for a sum? 120, 135. Any other sums? All right, how about subtractions? What are we using for some subtractions? What do you got? 300 minus 45. Any other subtractions? I definitely have more, right? 315 minus 60, right? 315 minus 60. Again, there's got to be like a 45-degree angle in all of them because we're ending with a 5. So if you just pick a 45-degree angle and then figure out what you have to add and subtract to get to it, right? Grady was asking, can I use a negative? Sure, I can use a negative. So I could do 300 plus negative 45. All right, so you could totally do that, and then you're just going to use odd and even identities. So you should be getting some red 6s, some red 2s, probably over 4s. Does it make sense that both of my decimals, when I hit sine of 255 and cosine of 255, does it make sense that both of those decimals came out to be negatives? Why, Noah? Very good. They're in quadrant 3, right? So see how all this stuff with trig, right, is coming back to each other, right, from the beginning of stuff, okay? So we're going to take like a minute. You guys are going to get with everybody else that did the same problem. You're going to compare your answers, all right? So anybody that did sine sum, you're going to come up in this corner. Anybody that did sine difference, you're going to go back there. Anybody that did cosine sum, you're coming up near my desk. Anybody did that cosine difference, you're going back in that corner. First thing I want you to say is what you used and then what you got as an answer. Help each other if you don't match. Help each other if you don't match. Sine sum, sine difference, cosine sum, cosine difference. There should be 4 people in each corner, right? So again, numbers that you used and then what you got as an answer. It should be really quick, like 30 seconds. Once you're done, go back. Any issues? Does anybody need to see their problem? Anybody need to see their problem? You good? So you guys get that we have those two rules, right? To me, they're the same, whether it's addition or subtraction. But how many does it count for? Those 2 rules actually count for how many functions? Not just 4, 8, right? So sine, sum, and difference count for cosecant, sum, and difference. So that's 4, right? And then cosine, sum, and difference count for secant, sum, and difference. So that's another 4. Okay? So Connor, what are we doing next? What are we doing next? Which one's going to come next? Tangent, right? So we're going to do tangent sum. Tangent sum. So Sam, what do you think I'm going to do with sine and cosine to get tangent? Divide them, right? So I'm going to say tangent sum is going to be the sine sum over the sine difference. Whoops, sorry, I lied. Sine sum over cosine sum. Okay, sine sum over cosine sum. So what I'm going to do is take those 2 and plug them in. So I'm going to go sine, cosine, cosine, sine, and match it. I'm going to go cosine, cosine, sine, sine, and switch it. So we're not going to leave it like that though, right? Because I'd be plugging in 8 different fractions there, and that would be a pain to simplify. So what we want to do is we want to get tangent involved. We want to get tangent involved. So how can I take all of these guys right here and only get tangents? Only get tangents. Hint is you want to multiply by a convenient form of 1. So what is that convenient form of 1 going to be so that I don't have any sines or cosines left? Ready? Either sine or cosine. All right, well, give me something and I'll try it. Sine. Sine of A, B, both. What do you want? Okay, so let's check. If I do sine of A, and I'm giving you a hint that it's 1 over. So if I multiply this by sine of A, well, I've got a cosine of B left over here, right? So that's not going to work. Somebody try, give me something else. Give me something else. Connor? Both cosine? Cosine A, cosine B? That's what it's going to be, right? So hopefully you would think, right, that it's got to have cosine in the denominator, right? Because that's what I need for a tangent. So let's see what I get. I'm going to get sine A cosine B over what Connor just gave me, plus cosine A sine B over that same thing. And then I'm going to do it 2 more times. Cosine A cosine B over this. And then sine A sine B over the cosines. All right, Parker, what can cancel? What can cancel right here and what's left? Which is tan A. Lauren, how about right there? What cancels? Top right. Cosine A's, and what do I have left? Tangent B. All right, Alex, how about over here? What cancels? 1, very good. All right, and Donovan, how about over here? Nothing cancels, right? What does it turn into? Tangent of each of them, right? Tan of each of them. So there you go. There's your tangent rule, all right? So again, the way I like to say it, I like to say tangent of the sum is tangent of the first, tangent of the second over 1 minus, then multiply together. All right, Max, how is it going to change if it's a subtraction? The signs are going to flip, right? Signs are going to flip. So how are we going to remember? How are we going to remember that if it's a sum, it matches on the top and it switches on the bottom? If it's a difference, it matches on the top and it switches on the bottom. How are we going to remember that? How are we going to remember that? Ryan, what is tangent in terms of sine and cosine? Sine over cosine. So doesn't the sine in the sine match, right? So again, if you remember up top here that the sine matches, well, then it's easy to remember match and flip, right? Match and flip. So even though tangent can be a pain, this formula is a lot easier than plugging in 8 different things. And again, we've got one formula for 4, right? Because it's cotangent, sum, and difference as well. Now, someone asked this in the last class. They said for cotangent, do we change all of those to cotangents? What do you think? What am I going to do for cotangent? Do I change them to cotangent? What do I do, Ryan? Even easier than that. Just flip the whole thing, right? Just flip the whole thing for cotangent, right? Flip the whole thing. So if it's cotangent, we're just flipping the whole thing, okay? So let's try one, right? So again, we're going to do the same thing. Some people will do some people will do difference. So we did 250, actually, let's do one together first. Let's do tan of 255 together first, right? 255 together. So I'll do 210 plus 45. Actually, 210, do I want to do 210? Yes. Tangent of 210 plus 45. So that means it's tangent of 210 plus tangent of 45 all over 1 multiplied together. I always go for my 45s first, right? So 45's quadrant 1, so that is positive 1. All right, 210, 30-degree reference angle, quadrant, excuse me, 3, so it's positive. So 30-degree reference angle for tangent is what? Rad 3 over 3? Rad 3 over 3. The pain part of this is rationalizing. So I get rad 3 over 3 plus 1 all over 1 minus rad 3 over 3. So right there, I could multiply by the conjugate, but it's actually easier to get rid of the complex fractions first. So I'm going to change the 1 to a 3 over a 3, right? Make all the denominators the same first. Then all the denominators will disappear, and just make it easier to rationalize for yourself. All right, so I'm going to rationalize by multiplying by 3 plus rad 3. And let's see what we get. We get, what, 12 plus 6 rad 3 in the numerator. Denominator, I get 6. I know I skipped a step, right? But let's see, I get 9 plus 3. That's my 12. And I get 3 rad 3 plus 3 rad 3. Then on the denominator, I just get 9 minus 3, 6. So I've got 2 plus rad 3. Donovan, is 2 plus rad 3 positive or negative? Positive. Does it make sense that tangent of 255 is positive? Does it make sense? It does, right? So you guys go get the decimal of 2 plus rad 3. I'm doing tangent of 255 in my calculator. Does it match? 3.73? Right? It matches. Okay, so you guys try another one. Let's do, again, try to think of another good one. You don't really want to do quadrantals in this, right? Because quadrantals could be undefined for tangent. Hey, let's have you do cotangent instead. Do cotangent of 165. I don't care if you do add or subtract. You decide, right? So just try to do something different than your partner, right? So cotangent of 165. So all you are doing is you are flipping your fraction, right? You're flipping your fraction. Flipping your fraction. Flipping your fraction. Can I do 180 minus 15? Can I do 180 minus 15? 180, 15. Why not, Donovan? I don't want to use quadrantals, but the bigger problem's the 15. 15's not good. It's not one of the unit circle angles, right? Not one of the unit circle angles. Yeah, 90 is a tough one because 90.
Yeah.
Yeah. So what? 135 plus 30. You could do 45 plus 120, right? You could do a subtraction. Did anybody do a subtraction or did you all do an addition? What'd you do for subtraction? 210 minus 45? Oh, that was nice because we just did that, right? Too bad I didn't save my work. $165 is in quadrant 2, where tangent is negative. No, none of those are going to be undefined. 135 has got a 45-degree reference angle, right? So 45 is 1. Quadrant 2, it's going to be negative 1. Right? Are you okay with 45-degree reference angle? Right? Do you guys get why I like made you drill the unit circle and not look at it all the time, right? Because again, you need to know these rules. I kind of don't like having the radical first. I like having the radical second. Nine, 12. That's wrong though. What did I do wrong? I know I flipped to the bottom. Why doesn't that work that I did that? Oh, no. Hmm? It should match. I have a subtraction. It should match over the sum. 210 is quadrant 3. Say it again. Oh, thank you, thank you, thank you. Right? It's cosine over sine, right? Cosine over sine. So now I'll keep it. So that's 3. That's 9. That's 12 plus 6 at 3. I guess I should have done the other conjugate, right? So that's 3. That's negative 6.
Oh, you didn't flip the negative.
I did or didn't? Hold on, I'm confusing myself.
Multiplied it out in the bottom left. So 3 minus 3 over 3 plus.
Thank you.
Wait, no, it's the other 3.
Thank you. So I get 6. 9 minus 3, 6. 12 plus, why do I still get positive though? All right, let me just think 1 second here. So it's a subtraction, so it should be cosine over sine. My signs are good. 1 plus tangent of 210, tangent of 45, tangent of 210, tangent of 45. 1 plus, we're at 3 over 3 times 1. We're at 3 over 3 minus 1. So, there we go. I got it. So I got 3 plus rad 3 over rad 3 minus 3. So then I go rad 3 plus 3, rad 3 plus 3. I go 12 plus 6 rad 3 over negative 6. There we go. Negative 2 minus rad 3. You guys get negative 2 minus rad 3? All right. Did you say close enough, Lauren?
Yeah, I got
Not close enough. Right? So again, that's why I just kind of had to do my signs and check my signs. 120 is quadrant 2, which is negative. So shouldn't that be a negative, which turns it into a plus? And shouldn't that one be a negative? Right? Is that okay? You did tangent and not cotangent, though.
I switched it.
You switched afterwards? Okay. All right, so you guys okay with that? I had to go slow on that one. Yep, Molly?
You do all tangent.
Yeah, totally, right? So Molly's asking if you could do it as a tangent, and then once you're at like this point, flip it. Sure. Yeah. Because we could have just taken our last answer and flipped it, right? Because I use the same numbers. So we could have just taken our last answer and flipped it. Yep. Okay, so what did you use? Tan of 45 plus 120. So if you're doing it as a tangent, right, this is what you should have had, which I believe that's the one that Lauren did and messed up a sign, right? So you got 1 minus, you got a 1, you got a 1, 20. So 120 is 60. So what's that, rad 3? Negative rad 3? Because 120 is in quadrant 2. Did you have negative rad 3? Okay. Yeah, that's why. So you got 1 minus rad 3, 1 plus rad 3. I would flip it there, right? I would flip it there. So 1 plus rad 3 over 1 minus rad 3 to make it a cotangent, and then rationalize. Yeah. Yeah. You can flip it here, you can flip it here, you can flip it here. You just have to make sure you flip it. Yes. Right? But I wouldn't rationalize and then flip it, because you might have to rationalize again. Right? You might have to rationalize again. All right, is that good? Right? So if I were you, right, I would make sure that on your formula sheet, right, you have all of these 3 rules that count for 12, right? All of those 3 rules that count for 12, 1 for 4. Okay, is that good? All right, next problem is probably one of my favorite problems. And the reason it's my favorite problem is because it definitely kind of brings back things that we have done, and I can do a bunch of versions. Okay, so I'm starting with a type of problem that we've done in lots of sections. I gave you sine of theta is -1/4. I gave you cosine of alpha is 3/5. We are not going to do all of these 6 because it's all pretty much the same work. And realize that I could make it into 12 problems, right? I can make it into 12 problems by changing all of these to reciprocals, right? So I can give you this one set of directions for 12 different problems. What do you think we do? Liam, pick one. Sine, cosine, tan, cosecant, secant, cotan. Cosine, okay? Alex, pick sum or difference? Sum. So we are going to tackle cosine sum. All right, so cosine of theta plus alpha. So I'm going to use my cosine sum formula. So my cosine sum formula is cosine, cosine, sine, sine. I'm just writing smaller so that I can fit it all on one line. So cosine, cosine, sine, sine. Can I plug anything into that problem as my directions sit there now? Can I plug anything in? Claudia, am I given either cosine or sine theta, cosine or sine alpha? Okay, but I actually don't need to solve for my angle. If I wanted to solve for my angle, which I'm going to do at the end to check, right? But I just want to know what the cosine sum is of those angles. So out of these four, don't I have 2 out of those 4? Brady, which 2? I have sine of theta, so I'm going to go plug it in. And then what else do I have? Alpha. I have cosine of alpha, 3/5. I don't have cosine of theta. I don't have sine of alpha. Anaya, how am I actually going to find them? How can I find them? I can do it 2 different ways. I could do cofunction, but I don't know if that's going to help. I don't know if cofunction is going to help. Pythagorean's the better. Pythagorean or draw a triangle, way back to the original drawing triangles, right? What type of triangle is this one, though? If I give you 3/5, 3, 4, 5, right? So isn't sine of alpha 4/5 for our 3, 4, 5 triangle? Parker, positive or negative? Positive or negative? Because quadrant 1, right? So sine of alpha, I know that's my 3, 4, 5 triangle. So I can plug in 4/5. So if it's not one of those, like the first one, I'm going to do sine squared plus cosine squared equals 1. So cosine of theta is going to be positive or negative rad 15/4. Donovan, which one, positive or negative? Negative. So I'm going to know that the cosine of theta is negative rad 15/4. Right? Do you guys get that we've done this problem before, right? Now I'm just making it harder by putting 2 of them together. So we got negative 3 rad 15 plus 4 all over 20. And that's my exact value. Let's check yourself. Go get a decimal for that. Go get a decimal for that. I don't know what I did with my calculator. Go get a decimal for that. You guys get negative 0.381? Right, negative 0.381. All right, so let's see if that matches. Claudia kind of gave you a hint before of how you can check yourself, right? So let's check ourselves. Sine of theta is -1/4, and I'm in quadrant 3. Go find me theta. Sine of theta is -1/4, and I'm in quadrant 3. What's theta? What's theta? Anybody think they have it? Kind of looks like he's done. What'd you get? What'd you get?
I got -14.
Okay, so you did it in the calculator correctly, right? But what does -14 mean? I'm hitting the inverse sine function. So it's getting me an answer in quadrant 4. That's negative because that's what inverse sine does. So I've just got to transfer it to quadrant 3. I got 194.478. Did anybody else get that, right? I got to put it in quadrant 3. So now go get alpha. Go get alpha now. Cosine of alpha is 3/5. Go get alpha. Do you get 53.130? Right? Quadrant 1. So I don't need to do anything to it. So now let's check your answer. Do theta plus alpha. I'm getting 247.61. I didn't round off. Do cosine of that value, and it should get you -0.381. Cosine of that value. Yay, it matches. Okay, that's a tough one. You see how I like that though? It brings so many different things in. So many different things in. Degrees, yeah, degrees. All right, so let's have you guys try another one. All right, let's have you guys try another one. You guys try, what was that cosine sum? So you guys try tangent difference. Tangent difference. Half of your work is already done for you. Why do I say that? Why is half the work already done for you? Hedda, what do you think? You already have, you mean your angle values? You do have your angle values, right? So theta is going to be theta, alpha is going to be alpha, so I can check yourself. What else do I have already written on the board though, Dave? Oh, even easier than that. You're making more work for yourself, right? Don't I have sine and cosine of alpha? So can't I get tangent of alpha really easily by going sine over cosine? Right? 4/3. You could totally do what you're doing, right? You have cosine, so you could make that your denominator and just do sine. But is it easier to plug in 4 items or 2 items? 2, right? So you already have sine and cosine of these guys, right? So all I don't know what it's doing here. Right, so I already have sine and cosine of those guys. So if I just do my tangent difference formula, right, tangent difference and get my tangent, then I can just plug them all in. All right, give it a try. This is a pain to simplify. This is a pain to simplify. Give it a try, see what you get. We have sine and cosine, so you got to go find tangent, right? So you write your tangent difference rule, and then you're going to plug in tangent of theta and tangent of alpha. You were like guaranteed to have one of these on your quiz, guaranteed. Guaranteed. Again, I can make so many, I could really make 24 different versions of this problem with the same instructions, except change the angles. And I can make 24 different versions. Okay, so if you're doing tangent difference, right? So you got your rule. So now if you go back up to the beginning, right? Back up to the beginning, so write this down. Sine of theta is -1/4. Cosine of theta is negative rad 15/4. Cosine of alpha is 3/5, so write it underneath that one. And sine of alpha is, what was it? 4/5? 4/5. Okay, so now isn't tangent sine over cosine?
Oh yeah, when do we get these like in this?
We got those from up top in the beginning directions by doing Pythagorean and by doing the 3, 4, 5 triangle, right? So now if you have sine and cosine, you can easily plug those in. Does that make sense? I'm going to just cut it and give myself some more room. What are we doing? Tangent difference? I could actually make, going crazy now, 48 different versions, because I could just flip the order of the alpha and the theta too. I could make 48 different versions. That's spectacular. All right, so I'm trying to just clean my problem up a little bit. Do you guys understand that that's all we need? Right? That's all we need. So from the original directions, I have sine of theta is -1/4. Cosine of theta is negative rad 15/4. So that means tangent of theta is 1/rad 15 or rad 15/15, right? Because I got sine, I got cosine. So I can go plug that in. Rad 15/15. All right, so my alpha stuff, that's a little easier. Cosine is 3/5, sine is 4/5. So tangent of alpha, 4/3. Is that okay with all my plugins? All right, they're complex fractions. So what do I want to make as my common denominator? Give you a hint, it's not 15. What's my common denominator? Isn't it 45? Right? So I want to make this one 3 rad 15/45. I want to make my 1 45/45. I want to make my 4/3. I don't want to make a mistake. I did last class. 60/45. Right? Is that right? All 45s? This is the place people mess up. 3 rad 15 minus 60 over 45 plus 4 rad 15. Is that okay? What do I have to do? Rationalize? Perfect spot to end, right? We would rationalize. I know you can all multiply. I wouldn't give you a tangent and a cotangent one because the pain in the butt is rationalizing it. Okay? All right. We'll continue when we get back. So much. All right. So can we pick up on this, guys? Put your phones away. Right? So on this one, right, you would want to multiply by the conjugate and simplify, right? So again, I know you guys can all multiply. I'd give like a tangent or a cotangent as like a bonus, but I would definitely give a sine or a cosine on your quiz. Okay? Like a good problem just because it incorporates so much stuff. Okay? Okay, let's do our last set of identities. Okay? All right, last set of identities. They're called multiple angle identities. So if I wanted to find, right, it'd be silly to do this, but if I wanted to find the sine of 60, what two unit circle angles add or subtract to get to 60? 30 and 30, right? So if I were to do 30 and 30, right, and it's a sum, so I'd go sine, cosine, match it, cosine, sine. Aren't those two things the exact same? Sine of 30, cosine of 30, right? So I could take those two and I could put them together and I would do 2 sine of 30, cosine of 30, right? I could go plug it in, right? Sine of 30 is a half, cosine of 30 is rad 3 over 2. I would just get rad 3 over 2. I know I'm correct because 60 is a unit circle angle, right? So there are going to be 5 multiple angle identities, right? 5 multiple angle identities. So instead of going sine of 30 plus 30, I can do sine of 2 times 30, right? So I would go sine of 2 times 30, and it would be 2 sine of 30 cosine of 30, right? And that's just what I had right there. Okay? So you should be able to prove all of these. All right, so Keta, pick one of the cosine ones, first, second, or third. Second one? Okay, so I am going to prove that rule, right? This could be an identity, right? So we have the left-hand side. We have the right-hand side. So I need to make these two match. So on the left, I would do cosine of x plus x. So then I would use the cosine sum rule. Cosine, cosine, switch it, sine, sine. So if Keta picked the first one, I'd be done, right? Because I'm matching the first one. She picked the second one. So how do I turn that one into the second one? Yep. So take sine squared and change it to 1 minus cosine squared and distribute my negative. I'm left with 2 cosine squared minus 1, right? So that could be an identity that you're asked to show why it's true, right? So we actually got two of them. I got the first one by the sum. So Keta said the second one, so I subbed that one in. If she said the third one, then I would have just subbed in for that side, right? So these are 5 more identities that you need to know, but those 5 really count as how many? 10, right? Because sine 1 over it's going to be cosecant. Cosine, all of those can be 1 over it is secant. And then tangent, I can flip it for cotangent. So the way you're going to use a lot of these is one thing that I'm going to save for tomorrow, right? So solving it for different angles, right? Different angles. So you had that problem last section. I'm going to save that tomorrow for our sophomores to be here as well, okay? But the other way that you can use them is for different identities. I thought I already had this open, but I do not. So I am going to open the homework and pick some of the identities that use these. So as I said earlier in the class, right, I said you could do up to 46 or so, right? And it would be a good idea to work on some because it does get a little long. So if I look at the first page of them, the ones on the left, that's everything that we've done so far. Sum, difference, sine, cosine, tangent. You can see pi over 12 is used often. How many degrees is pi over 12? How many? 15, right? 180 over 12. So if you're in radians, it's no different, right? I could do 3 pi over 12 plus 8 pi over 12, which is pi over 4 plus 2 pi over 3, right? So radians, no different than we did. How about this right side? What do you think this right side is asking you to do? Look at that right side. Do you think I should be plugging in values to these? Do I know a value for cosine and sine of pi over 7? Pi over 7 is not a unit circle angle, right? So what they want you to do on this side is they want you to say, okay, this is a cosine difference, I'm sorry, sum rule. So this is equivalent to cosine of the first plus the second, right? So they want you to kind of take the rule that they gave you and say where they started from, okay? So I think you guys should be able to handle all of those, right? So look at the next set, okay? So the next set are some identities, right? So let's look at this set up to 30. Molly, pick one, 23 to 30. 26. That's funny because that's the first one that the other class picked as well, right? It kind of looks hard, but let's do this. So this is an identity, right? So let's do this one. I have to make the left match the right, right? I got to make the left match the right. So again, we're going to pick the harder side and we're going to try to make it look like the easier side. Liam, which one do you think is the harder side? The left, right? But all the left is a cosine difference, right? Cosine difference. So I'll do the cosine difference rule. Cosine of the first, cosine of the second, change the sign, sine of the first, sine of the second. So that's still not matching the right. What am I going to do to try to match it to be the right? When you have pi over 2 minus x, what type of identity should you think of? Lauren saying co-function over here, right? So your co-function is sine of x. Your co-function is cosine of x. Donovan, does it match the right side exactly yet? It actually does, right? We just have to change the look of it. This is the sine sum rule. So we have to make sure it matches exactly, but I can do that as the sine sum. Okay, let's try one more. Yeah? How did I get from this to this? From here to here? Cosine difference rule. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. Would I have to have used cofunctions? Would I have to have used cofunctions? Again, since I'm probably asking the question, no, right? What else could you have done from this step to that step? What else could you have done? What else could you have done? What are you saying, Parker? Another difference here and another difference here, right? So I could have done a difference again, but then I'd have to distribute the cosine y there, but it would still work, right? It would have still worked. All right, let's pick another one. Noah, pick one. We just did 26, so pick another one. 29. Okay, so again, 29, it's a tangent one. You guys give it a try. Try the tangent sum rule. Tangent sum. Tangent sum. All right, tangent sum on your left. Tangent sum on your left. Tangent sum, tangent of the first, tangent of the second. 1 minus them multiplied together. You match the top and you switch the bottom. Whoops. Should be 2 steps, right? I applied the rule, and then what's tangent of 45? Tangent of 45 is 1, right? So I'm done, right? Tangent of 45 is 1, so we match. Oops, I have to put a 1 there. All right, so it matches. Okay, let's try an expression one. All right, let's try an expression one. Let's try. All right, so again, I said you guys could do up to 46. You don't have any of these graph ones because you would just put it in your calculator and graph it, right? And then I don't want you to do any equation ones yet, right? Because that's what we're going to do tomorrow. So let's pick an expression one. Let's pick one of these. All right, and now I pick 53 to 56. Pick one of those. 53. Actually, 53 is really easy. Can you pick another one? 54. Okay. The reason I say 53 is really easy because it just gives you 1 theta. So it's actually pretty easy. All right, so let's do 54. So the directions for 54 are only have thetas, right? Only have a trig function of theta. So this has a 2 theta. So I have to get rid of those 2's. So that's where your multiple angle identities are going to come into play, right? So we're going to go back a couple of slides, right? And we have to use these rules. So I have sine of my double angle, and I have cosine of my double angle. Okay, so sine of my double angle. I'm actually just going to put the problem right here, right? So sine, I have that for my problem. So sine of my double angle, I can make a straight substitution. That's 2 sine of theta cosine of theta. Cosine double angle. Ryan, pick one. 1, 2, or 3? 1. So I'm going to put in cosine squared of theta minus sine squared of theta. Do I have just single thetas? Do I have any coefficients in front of my theta? I don't. So that could be an okay answer. You kind of want to look, can you do anything else? Can I sub 1 in here? Nope, it needs to be a plus. Can I rearrange? Can I rearrange and factor it? Can I rearrange and factor it? It would need to be a plus sine squared to factor it, right? If Ryan gave me something different, let's say he gave me the second one, right? Let's say he gave me the second one. Can I rearrange that one and do something to it? I can't, right? So when you have something like this, when it says 2 theta, right, then you just want to have thetas following it. Okay, let's try one more of those. You guys try this one. Try 56. Sine of 3 theta plus cosine of 2 theta. What time are we leaving? 12:43. Sine of 3 theta plus cosine of 2 theta. 3 theta and 2 theta. 3 theta and 2 theta. 3 theta, 2 theta. So realize these are your expressions. You don't know where to end. Claudia, what do you think we should do for the 2 theta one? Yep. Yeah. So pick one. First one. So Claudia is saying the first one for the cosine. Again, equivalent expressions, right? Equivalent expressions. So you can't be lazy and not write the sine of 3 theta one. We don't have anything with 3 theta. So what are we going to change that one to? Any ideas? 2 plus 1. All right, so let's see where that gets us. 2 theta plus theta. All right, so let's see what it does for us. So now I need to use sine sum, right? Sine sum. So sine, cosine, cosine, sine. These get a little long. All right, so now I got to do sine double angle. Sine double angle is 2 sine cosine. So 2 sine cosine, but I got another cosine, so it's going to be cosine squared. I got to pick another one for this one. I don't know. I don't want to use that one. Are any of them better than others? I don't think so. I'll use this one. We haven't used that one yet. So I'm subbing that in as 1 minus 2 sine squared. They're a little long, right? And then I'm just going to distribute. So let's see if I can do anything after that. Alex, you'll like even these better with all of these thetas that you have to write. Can I combine anything? Can I combine anything? I don't think I can combine anything, right? None of them match. None of them really have anything that I could GCF out of all of them. I could GCF out of some of them, but I don't think it's going to do anything for you. Okay? All right. So if I were you guys, I would definitely do some up to 46, right? Whatever it says. I forget what I put on there. right? So whatever it says, up to 46. And again, it says 3 to 30 by 3s, 36 to 63 by 3s, right? So I would do up to 46, so it's not so big over the weekend.
Still an acceptable answer. Like if you do this, just go into those two instead of.
Yeah.
obviously-
I mean, you would want to distribute out, right?
Oh,
Yeah,
so
you,
get-
because look at, if you distribute this out and this out, then you could combine them.
Yeah.
Yeah, you'd want to distribute out. Okay? Nope, nope. So Grady's saying he changed it to the first one, and we could actually simplify it a little bit. So maybe the first one would have been